Welcome to the Cloud Academy office hours, April 2017. This is the first time that we are doing this, so hopefully it continues. So we got this idea for this kind of webinar from the past webinars that we've done, in that we had a lot of beginner to intermediate questions and some recurring questions. So what we wanted to do was put together a session where anyone could come in and get their questions answered and listen to some discussions and kind of get some helpful information in a real-time format. So that's what we're going to do here in this office hours session. And again, hopefully if it works out for all of you, then we can continue doing it. So if you found this valuable, then do let us know. So my name is Adam Hawkins. If you've joined some of the past webinars, you may recognize me. I've done the webinars on Docker and Kubernetes, and also the Docker and Kubernetes courses on Cloud Academy. And if you want to read more about me, you can check out the link there to my blog. So what we're going to do here in this session is pretty straightforward. It's an open discussion based off of your questions only on these primary topics. We're mostly talking about Docker, Kubernetes, and AWS, and general cloud computing and, say, tech and deployments and all that kind of stuff based off of your questions. So how this will work is all of you are free to write your questions in the chat, and I will see those questions, and I will just answer as many as I possibly can in the hour that we have. And the ones that I can't answer now will be answered in a written summary on the Cloud Academy blog. So if you would like to catch a written summary of all of the things discussed in this session, and also the things that I could not answer, you can check the blog post hopefully in the next week or so after this session completes. So again, all that I ask of you is that you put your questions in the chat. Try to keep it primarily on these themes, but if you go a little bit off topic, that's no problem at all. I will do my best to answer all of the questions that you have, and I hope that I can answer your question. So without further ado, let's get this going. So I will kick it off by answering some common questions that come up in the realm of containers and Docker and all of that stuff. So one common question is, how do things like Docker Swarm and Kubernetes and Dcos differ? This is a common question, and it's a very good question because it gets to the heart of what these different tools do. Now, they're quite similar in that they are container orchestration tools, and what this means is that they offer abstractions for building and deploying containerized applications. So these give you sort of the abstractions to say, I want to run five of this container, I want these groups of containers together, I want to be able to network these containers should be exposed to the public internet, these containers or these groups of containers should be public, different levels of reliability, volume mounting, things like that. So that's what we mean when we talk about container orchestration. Those three tools, again, Kubernetes, Dcos, and Docker Swarm, are container orchestration tools. Now, the way they differ is in their kind of level of abstraction and the things that you can do with them. So let me first talk about Docker Swarm. So Docker Swarm is a first-party container orchestration tool by Docker Inc. And this is directly integrated with the Docker CLI and the Docker API. So when you create a Docker Swarm cluster, you actually have a cluster, so that's multiple machines compatible with a Docker API. So you can point your Docker client, your CLI, or even third-party API clients to that cluster and do Docker operations. With Docker Swarm, you have support for Docker Compose and all of those things that integrate directly with the Docker toolchain. So you can just deploy your application like that. Now, Kubernetes and Dcos are a little bit different. So Kubernetes was originally developed by Google. It's another container orchestration tool that is sorry, I lost my train of thought. Yeah, so Kubernetes is a container orchestration tool developed by Google, offering a little bit different level of abstraction. So compared with Docker Swarm, Kubernetes does not integrate directly with the Docker CLI. But conversely, Kubernetes actually supports multiple container runtimes. So at this point in time, Kubernetes, I believe, has support for Rocket, they call Rocket Netties. You have the same kind of abstractions where you can deploy containers, scale them, expose them, network them, these kind of things. And Dcos is similar in that way also. But Dcos is actually built on top of Apache Mesos, which is a more abstract workload, like a generic workload manager. So Apache Mesos is not necessarily just about containers, whereas Kubernetes and Docker Swarm are entirely about containers. So they offer similar levels of abstraction. Now, these are all different infrastructure things that you can run yourself. So Docker Swarm, you can build a Swarm cluster yourself. You can run that in AWS, GCP, or Azure, or you can even mix and match, say, physical and on-prem, virtual. The same goes for all of these different container orchestration tools. Now, the other area where these differ is maybe what kind of hosted options you have. So with Kubernetes, you can go to Google Cloud Platform and get Google Container Engine, which is hosted Kubernetes. And now, Microsoft Azure and their Azure Container Service also gives you hosted Dcos, Kubernetes, and Docker Swarm. Now, unfortunately, don't have a direct offering for these things on AWS. AWS only offers ECS, which is their proprietary container orchestration service. It's the Elastic Container Service. So ultimately, which one you decide to use really comes down to your own personal preference and also your requirements. So for example, right now, if you're using Docker Compose to, say, develop your application or perhaps even deploy your application, then if you want to stick with that, going with something like Docker Swarm makes the most sense. Now, if you want something that's a bit more flexible, or maybe actually not flexible, but if you want something that's a bit different and also not, say, done by Docker Inc., it's completely has more of an open source feel or ecosystem to it, something like Kubernetes or Dcos might be the best fit. But again, also Kubernetes is a little bit different in that it can support multiple container runtimes. And you get sort of the same thing with Dcos. So regardless of which one you'll pick, you'll get similar functionality, but kind of a different implementation and community support depending on the one that you choose. But regardless of the one that you choose, if you're interested in getting started with containers, then right now is a great time to choose one of these orchestration tools, get familiar with it, and use it to deploy your applications. This is not the way that it was a year ago. Now we actually have, there's many options in this area, which just weren't there a year ago. So what's the best way to learn how to use Docker and its capabilities? All right, so if you want to get started with Docker or containers in general, really the best way to get started is to try to build a simple application. This might be your kind of standard web application, anything like that, which will get you experienced with some of the Docker tools, mainly the Docker CLI, and especially some of the supporting tools around it like Docker Compose, which gives you a way to model, say, multi-container applications through a simple configuration file. Then you can also supplement that, of course, with guided instruction or blog post, there is a lot of content in the Cloud Academy webinars done by myself and others. There's also the Introduction to Docker course on Cloud Academy, which is available under free trial if you create an account. And just get going. But it's important to try to not jump in too far in the beginning, because this is a very deep pool, so to speak, so you want to wade into it a bit carefully. So start with building simple applications locally, getting a feel for how containers work and the abstractions that they offer, and then move up into trying to, say, deploy your application maybe onto a hosted solution, and then you can also try to build that infrastructure yourself if you're into that. Here's one question. Which one of these container services looks best suited for serverless microservices? So I guess the container services we're talking about are Kubernetes, Dcos, and Docker Swarm. Now, the question, we have to unpack it a little bit. There's two different concepts there. There's the container orchestration and serverless microservices. Now, serverless implies, well, okay, that there is no server. In this case, we're not necessarily dealing with containers. So if we can consider something like AWS Lambda or Azure Cloud Functions, there is no really containers there. You're not building containers, you're building individual functions. So none of those providers are actually about building serverless applications. So if you're talking about building serverless applications, at this point in time, you really have two options, which is Microsoft Azure Functions and AWS Lambda. So your personal preference will vary. I have used Lambda and it works, but my investigation into Azure also looks promising. So I think that whichever one you use between Azure or AWS Lambda, you'll be probably happy enough. But when it comes to building serverless applications, this is sort of a developing frontier right now. So when you get into this, you want to look at the kind of the ecosystem and supporting tools around them. Some of the tools may only work with AWS and not work with Azure. So that's something to keep in mind. Here's a good question for somebody looking to adopt containers. So we are still at we're still using virtual machines. What modifications do you suggest before we involve any container technology? So if you're already running in VMs, then it's not really a big jump to move to containers under most conditions. Now, it really depends on what sort of things your process in the VM relies on. Say, for example, persistent disks, things like that inside the VM, being able to, if you have, say, multiple processes running in the same VM, things like that. But if you're already working with VMs, it's not really a big jump to move to containers. As long as you're kind of working with stateless things and simply using the virtual machine as a wrapper to provide the kind of particular compute resources or like stack for the particular process that you run in the VM. But if you're running multiple processes in the same VM as kind of part of the same application, the first thing you need to do is split out those processes into one process per VM, and then you'll have an easier path to adopt container technologies. How would you migrate a traditional load-balanced application with the shared NFS directory to Docker? Would you mount the NF share on the host of every Docker host to make sure it's available on every server that the container could run on? So this is another question that sort of gets to the heart of what the architecture of containerized applications look like. Now, the solution presented in the question about mounting a shared NFS directory would work given that you run the containers, that you mount first the NFS volume on the host and then mount the host volume into the container. But what Docker allows you to do, and all of these, like say Kubernetes as your orchestration tool and Docker as the container runtime itself, actually abstracts this concept away in a term called volumes. Now, volumes is like your kind of block store. In this case, it could be a replacement for NFS, and those directories can be, say, AWS EBS volumes, or I don't remember the exact name of that similar feature on Google Cloud Platform, but these can be, say, very specific kind of technologies for disk stores, even like third-party or other open source things. So you can create a shared volume on something outside of the host, and then you can communicate that you can mount that as the particular volume in the container. So if you have that sort of shared state, there's ways to do it with the native volume support, but the better question to ask yourself is how can you remove the dependency on that shared volume? Now, I can't comment on that based off the question, but that's the first question you should ask when trying to move to a containerized application. Kubernetes mature enough to use in production? One word answer, yes. Go for it. So I would like to answer this question. How are containers typically used in the context of DevOps, specifically as cloud-based workspaces? If the person who asked that question could clarify what they mean by workspaces, that would be great. But at a high level, to answer the first part of the question, how are containers typically used in the context of DevOps? Well, at this point in time, I would say that containers are primarily used as a standardized infrastructure deployment target. So if you're working in a team that is trying to, or maybe not trying to, but is or trying to embrace DevOps principles, then you have multiple different technical actors sharing, working together in different parts of the system. Now, by adopting a container-based application, you have standardized the infrastructure to deploy, which means that independent technical teams can now build their applications in the particular language that they want. So if you're working in a polyglot team, maybe you have people experienced with, say, Java or Go or Python, Java, insert name of stack or technology. Your operations staff or your engineers can build the infrastructure to run any kind of those applications. So I think in a short summary, they are used to deploy any kind of application, and also by standardizing it, you enable, I think, higher velocity for more people in the team. All right. Are the container orchestration solutions open source, and is there any enterprise paid solution? So another question about containers. The Dcos is open source, Kubernetes is open source, and I believe Docker Swarm is open source. I don't actually, I'm kind of embarrassed, but I don't know exactly. I think it is. There are paid offerings specifically. So Kubernetes is open source. You can run it. There's no particular like enterprise offering for Kubernetes from the Kubernetes ecosystem because there's no like official Kubernetes company. Dcos through Mesosphere has a enterprise subscription, and Docker Swarm through what they call Docker Data Center has a paid subscription also, which gives you access to support, things like that. And then the way that these pricing models usually work is based off the number of machines you run the Docker daemon on, or the number of machines in your cluster. But there's also like third-party hosted versions of, say, Kubernetes, like I think Apprenda has something. There's a few offerings like that. So if you Google out hosted Kubernetes, you'll find some. I like this question. How do you see Docker or Kubernetes or any containers in a world 2 years from now or so? I like this one. So I think in a couple of years from now, I think what we will see is an abstraction completely from the container runtime itself. this would mean something like Docker is no longer really the center point of attention, because the orchestration tools, be it Kubernetes or whatever exists then, will be the main point, because people will have moved on from focusing on individual containers by default to focusing on multiple containers by default and how to actually deploy and operate them. So I'm sure that Kubernetes and Docker will still be around. I'm not sure what role Docker Inc. will play, but I hope that the overall sort of technical community and ecosystem can abstract out the role that the container runtime plays, like Docker or Rocket, in the orchestration tool space, and whichever container runtime is the most easily orchestrated will be the winner. I also hope that there will be multiple strong competitors for the container, like in the container runtime space, and hopefully AWS ECS will actually will no longer exist, as it will be usurped by open source tools, which I think is actually really interesting to see what Microsoft Azure is doing right now with their Azure Container Service. If you compare AWS, GCP, and Azure, AWS, surprisingly, is the only one with a proprietary container orchestration tool. Azure actually runs Kubernetes, Dcos, and Docker Swarm, which is kind of surprising me coming from Microsoft. So I hope that we also have more options for container orchestration, and also to come back to one of the other questions around serverless, that using abstractions like the ones in the orchestration tools like Dcos or Kubernetes, then it becomes easy to also do things like build quote serverless applications, is basically composed of functions on the same technologies that we could use, or the same technologies that we use to deploy containers. Next question. I want to know how should I persist data in Docker, how each container in Docker can talk to each other. My question is in regards to Docker networking. So two-part question. One, how to persist data with containers. Touched on that already, but that comes down to using volumes and choosing the particular volume driver that makes sense for your particular requirements. This might be just a host file system, or an external network volume, or even a cloud block store like EBS. So the second part of the question is, how do Docker containers talk to each other? Now, this is quite a complex topic, and it's certainly not my core area of expertise, but I will give you the big picture of how it works. So on current versions of Docker, you create what's called a overlay network, you basically create a network where all of the containers run in. Now, if those containers have a name, say you might have a network where you have your quote back-end container and your front-end container, then your back-end container can resolve the front-end container and vice versa. You can also expose container ports to Docker hosts. Then, for example, if you're running a container and the process in the container is running on port, say, 8080, you can pass options to Docker run to expose port 8080 on the host, and then you can, talk on that port. But container networking is a really big topic, and I'm really not doing that topic justice, but it's just that there is a network of those containers, and due to the way the network is constructed and the different networking drivers, the different networking software involved, the containers are able to find and resolve each other. Okay, here's another question. How do we compare Docker versus Kubernetes versus AWS ECS in terms of rapid deployment and managing NFRs thereof? I never actually heard the term NFR, so I'll just take the first part of that question. So first of all, the thing to unpack is you can't really compare directly Kubernetes with or AWS ECS with Docker. So Docker itself is just the container runtime. That gives you the capacity to run one container. Kubernetes and ECS are about orchestrating multiple containers. So a more accurate way to state that question would be to compare Docker Swarm versus Kubernetes versus AWS ECS. At that point, we're talking purely about container orchestration tools or deployment tools. So how do you compare those? Is sort of looking at what features are available and what kind of features that you need, and also the pace of iteration on the project itself. Kubernetes is actually one of the most popular projects on GitHub in terms of, I think it's either contributors or pull request issues, some metric like that. So Kubernetes itself is evolving very fast. Docker Swarm is also evolving very quickly compared to ECS. ECS is at Amazon's pace, which is much slower or different than the open source community. And thank you for clarifying that NFR is non-functional requirements. So if you look at things like performance management, then with, say, ECS, maybe you're mapping that in terms of your AWS instances, whereas with Kubernetes, you can be using, say, physical machines of any spec that you can create. Maybe using cloud VMs with, say, an AWS instance or GCP machine type. You start to deal with, say, how can I ensure that this container gets this amount of CPU or this amount of memory, and this container is capped at this amount of CPU or this amount of memory, and seeing how those different tools enforce some of those requirements. Next question: what skills are required for Docker or Kubernetes learning? Do I need to have prior coding skills? No, you actually don't need any real coding skills, but you will need to understand, you will have to have built an application before. So you don't need to know how to code to start working with containers, but you won't be able to apply container technologies without understanding how to, without having ever built an application before. Like the things that you would do when, say, building a web application or say compiling some software, you'll need to have a set of, all the dependencies installed, things configured in a certain way, and these are some of the things that containers can abstract away for you or encapsulate. But if you've never had that kind of experience, then it's going to be hard to just dive right in to working with containers. Question: what do you prefer, a stack of applications, Dockerized, or separate containers of each application interacting with each other? Let me do my best to understand this question. Not exactly sure what a stack of Dockerized application means, or separate containers for each application interacting with each other. I'm not sure what the first part means, but I tend to the second half of the question, which is separate containers for each application interacting with each other. To me, that makes more sense. To have one container per different kind of process of your application, not necessarily applications. So an application may contain multiple processes. So consider an application that has a web server and also a background job processor. That's two processes. In my preferred architecture, each of those processes would be a single container. Or would be modeled as a container. And then when you need to scale, you can say I need N of the server and M of the background processor. But certainly my preference these days is for completely containerized applications, if possible. If I'm entering a greenfield, then I would use containers without even thinking. And my current preferred deployment, or my preferred container orchestration tool, is Kubernetes. So next question: among the orchestration tools, is there a clear market leader? Now, I don't think that there is a clear market leader, but I think there is a sort of a strong community or your technical gravity towards Kubernetes for one reason or the other. Yeah, so not really a market leader, but definitely a technical or thought leader. Go for Kubernetes. Okay. So next question. Are containers used in large enterprises, or is the technology still evolving? Well, now the technology is certainly still evolving, and are they used in large enterprises? The answer is maybe. Now, if you look at what's happening, they may not be used to run entire systems for that enterprise, but they may be used in smaller systems in an enterprise. And I think where we are right now with containers is bigger companies are starting to come into that adoption curve where we see, bigger companies adopting this and more of more growth around the ecosystem and supporting tools and vendors and all of those things. But containers themselves, the containers actually aren't really even new. What we see in the past couple of years is really an explosion in popularity due to Docker lowering the barrier to entry to work with containers. I mean, Docker itself is really built on technologies in the Linux kernel, and what it did was just sort of make it easy for people to apply those technologies to a particular problem space. So the use cases that we have for containers are still evolving. Now, where the real evolution is happening is in the orchestration space. Because in the past year, maybe the past 2 years or so, we've moved beyond trying to use, say, one container for development or whatever. We've gone from development and now we're focused to production. And using containers in production is a very different problem space than using containers in development. So yes, the technology is still evolving, and are containers being used in large enterprises? Yes, and it just sort of depends where in that enterprise. But that being said, I would be really surprised if you found a company like, I don't know, a huge company, like especially a bank, like Bank of America or something like that, running their entire system on containers. But actually, I think now that I think about it, just talking about companies, I think Goldman Sachs is actually doing a lot of work with containers. So you can take that for what it's worth. Next question. Can you describe how a stack is implemented in the orchestration tool, or can you just point to them in your previous webinars? A stack is implemented in the orchestration tools. Okay, I'm not entirely sure what that question is getting at, but I'll do my best to kind of describe my my preferred stack. So what I like, or what I want to have is containerized applications deployed to Kubernetes on any cloud provider. It doesn't really matter. I would prefer to use Google Container Engine if I could, simply because I don't really want to have to run Kubernetes. And I would use Helm, which is the kind of an application package manager slash deployment manager kind of thing for Kubernetes. That way I can upgrade, rollback, deploy my application. Next question. Serverless is a cloud concept. Is there a way to do serverless locally? The answer to that question is kind of, if you define what it means to run locally. Now, if you take the classic example, kind of ironic to say classic when it comes to serverless example, it's not that old enough to have earned a classic moniker, but if you look at the examples, which is, say, a simple Node.js function, that function has input arguments, and it returns something or calls a callback. Now, you can call that function locally. You can load that code file, require it, import it, whatever you want to say, and call that function to test it. However, say running it is a bit of a different story depending on what kind of serverless application you're talking about. Now, when we talk about serverless applications, this need not be entirely just, say, like HTTP. That's mostly what people are referring to when they say serverless applications, like a serverless RESTful API, for example. But if we take AWS, you may have an entirely serverless application that's just processing, say, SQS messages. Now, there's not really a way to run those, say, at least in the second case, to run it locally because you're reliant on AWS. Now, in the first case, where you're trying to map HTTP requests to these individual function calls, the answer is yes, you could run that locally if you were to create something that could, a web process or a web server that would accept incoming HTTP requests and map those to function calls and function responses to HTTP responses. That's what the AWS API gateway does. So the answer is, like, yes, you could, quote, run it locally, but it would not be exactly the same as if you were to run it in a production environment. Okay. Next question. Docker applications are usually smaller and complexities are masked. How do you weigh that with quick triage when something goes bump in the night and you have to restore an app quickly and the error is not discrete and obvious? Well, I'm not entirely sure what kind of complexities are masked by having a containerized application. So how do you weigh that with quick triage when something goes bump in the night? I guess what the question is trying to get to is how do you separate the complexities of, say, debugging potential things in the container runtime, i.e. like Docker itself, versus the application. Now, that kind of depends on how knowledgeable you want to be, in my opinion. Now, like, I'm guessing most of us, we operate at a chosen level of abstraction where we don't, I mean, we understand the lower levels, so we don't know so much about them. Like, the same question could be said about, or this could rephrase it to say, if something goes wrong in the kernel, what are you going to do, or do you need to restart it? Well, you could say restart the machine, who knows? But when you adopt any technology, regardless of if it's containers or even if you're going from physical hardware to VMs, the same sort of learning curve applies. Instead of dealing with, say, if I'm talking about a containerized application, then the lower level of abstraction that I look at is the container runtime. Below that, I don't really go any further. So if I move up one level and then forget about the layers below. So in the case of a containerized application, depending on the application, of course, but it's usually no problem to just restart the container. You can totally do that if it's totally messed up, and you just need to do fix a quick error, something like that. You can do those things. I'm not sure if I answered that question, so if you can put a clarification in the chat. All right. Whoever asked this question has got a good one, and this one usually comes up. So, question: what is the best way to monitor your containers, and what is different from monitoring containers versus virtual machines? All right. So, the difference is usually in the scale, but the same approach still applies. Now, let's just consider the concept of host monitoring versus container monitoring. Let's say that I have a machine somewhere, this could be physical or virtual, and want to know what's going on. So I would install something on that machine that will collect the metrics and report them. This could be something like your Nagios or collectd or insert name of metric thing. Pick one, it doesn't really matter. So that agent or process is running, collecting that data and reporting it to somewhere else. Now you can do that if it's a physical machine or a virtual machine. Now, the approach for monitoring containers is a little bit different. So if we talk about the Docker containers, you might have a machine that is running one container, or it might be running 50 containers or 100 containers, depending on the kind of system it's running and the compute capacity of the underlying host. Now, what you can do is install an agent that is running on your, say, Docker host. That's the machine running the Docker daemon that connects to the Docker API, or can read stats from the procfs on Linux, collect those metrics, and report them. But the thing that you don't want to do with containers is run sort of that kind of agent inside the container itself where the process is running. You want to collect those metrics from outside the container. So if we take something like Kubernetes, you want to monitor all of the containers running on your cluster, then you can install an agent running on the cluster that can talk to the cluster APIs and pull all of the metrics for those containers and report those upstream. So in general, the fundamental technical approach is, say, installing a process that can collect some metrics about the underlying processes running, still applies to containers. It's just talking to different ways to collect that data and send it to somewhere else. Next question: are containers a threat to virtual machines? Now, threat is interesting phrasing, but they are similar in that they can be used for kind of the same use cases, but I don't really think that they are a, wow. Maybe a better way to say that would be that in general, you probably can replace virtual machines with containers. Containers themselves are, the container architecture is more memory and compute efficient than virtual machines. However, virtual machines do offer abstraction that containers cannot. Like, I cannot run a Linux container on a Windows host, or vice versa, but I can run a Linux VM on a Windows machine, or I can run a Windows VM on a Linux host. So I don't think it's threat to me implies that it will sort of kill off that technology. I don't think that it will really kill off that technology, but I do think that for many people, containers will replace virtual machines. So if that's how you define threat, then yes, containers are a threat to virtual machines. Next question: how do you do MongoDB sharded clusters to be managed with multiple containers? So when we talk about databases inside containers, the thing that I always say is don't run databases in containers, because the general use case, or the problem domain that containers are best suited for, is stateless applications, like, say, a horizontally scaled application behind a load balancer, where containers can, or processes can come and go, and doesn't really make a difference. But when you start to talk about MongoDB and other sort of stateful things, especially, say, a MongoDB primary and replica, which is very stateful, you tend to have problems with running those systems natively in containers, because the abstractions and the facilities that the container runtimes offer don't really work well in that kind of model. So kind of a cop-out answer to the question about managing MongoDB clusters with multiple containers. My recommendation is just don't. I think you'll be in for pain if you try to run databases and things like that inside containers. I think it speaks to what we can do with containers as an industry. So question is, with persistence in mind, do you think that various traditional infrastructure services could end up being containerized, like on-premise, think DHCP, DNS, directory services, principals, etc.? Yeah, I think that they totally could. And there are people and projects who are trying to do everything with like native containers. I think this is true. I'm not entirely sure, but I believe that CoreOS is trying to run their operating system with everything in containers, which is pretty interesting. And I think that, you know, maybe farther in the future, it's totally plausible that some of these things that we think that's non-containers could be running in some form of a containerized environment. May not be something like Docker, for example. You might not have your DHCP server in Docker, but you might have that inside a containerized / sandbox environment on the system itself. And even if you look at what's happening in the Linux package management space with, like, what's it called, Flatpak or Snap, some of these things, they're pushing for or trying to bring in some of the features that you get with containers into the individual packages themselves. So to me, it's completely plausible that in the next couple of years we could see this kind of thing, and that sort of speaks to one of the previous questions about where do you see containers and this sort of stuff in a couple of years. So yeah, I think that is totally plausible. Next question. If I have a snapshot of an EBS volume, that's an AWS EBS volume, and delete the EBS, is it easy to attach and recreate the original EBS and continue the usage in that scenario, or can there be some data loss? That's actually a good question. I don't know if the snapshots themselves are actually tied to the EBS volumes, but I'm guessing the snapshots are actually backed up on S3 somewhere. So if you can recover that snapshot from S3, wherever it came from, you should be able to use that to recreate the EBS volume. So the only data loss that could occur in that scenario would be that if there is a lag time between when your snapshot was and when you wanted to restore data from. Okay, so I think that's all the time I have for. If I didn't have time to answer your question, I'm sorry, but I will do my best to answer all the questions in the written summary. So I thank you all for joining the session, and I hope that you liked it and you got something out of it. And if you did, please let us know so that we know if we should continue doing these kind of things. If you'd like to see more technical hands-on sessions with, say, Kubernetes or Docker, or working with any of these things, you can go to the webinars page on cloudacademy.com/webinars. Look for Docker, Kubernetes. You'll find some for myself and other people. And if you're interested in getting started, you can check out the Introduction to Docker course or the Introduction to Kubernetes course on Cloud Academy, which again are available on free trial. And I think that's a wrap for me. So thank you, everyone. Good luck out there, and happy shipping.